Well, welcome back everyone. Hope the first part of this video series gave you some insight into what soil sampling is and its importance. The second part here is we're going to look at kind of more of what's the process and the steps and those end results. And then kind of wrap up looking at what's coming down the pipeline or what we see in terms of the future with soil sampling. And then the third video series, I'm actually going to kind of go through kind of a whole process from creating the maps, uploading it to a mobile computer and all of that, and kind of see where that goes. So to kind of jump into that, we'll kind of, what is the whole process that goes on in soil sampling? Well, the first step is we're going to go into a software system that could be like Ag Leaders SMS, or there's another one out there called FarmWorks, quite a few others. Even the Hefty Brothers, the AGP HD, they have their own mobile app. You got to send the results to them. But, there's numerous software systems out there now where you could do that. But what you do is you go on that map and you're going to create your points, kind of like what you see there on the screen. So once you get those created, you're going to get those downloaded, uploaded, transferred over to some sort of field computer. And that field computer has a GPS, and that's going to allow you to navigate through the field, go find those points, find those grids, and then collect those samples. And key thing, we'll see this coming up here a little bit too, is, you want to make sure you keep things consistent. So you're always going to pull samples that are from a consistent depth. Once you have the samples collected, you're going to send those samples off to the lab. The folks at the lab are going to run their test on it, and then they're going to send you back the results. And you'll kind of see that comes up here in a little bit, but not only are you going to get a hard copy result, but you also get an electronic copy that we can just turn around and literally with the click of a button, pull those results back into that same software program that we used earlier on, and then we can start applying the results. Looking at the data and, run analysis, create prescriptions, do some follow-ups and compare, how has our soil fertility changed from 3 years ago to now? So that is kind of the basic sampling process from A to Z. So when it comes time to collecting a sample, the main things that you're going to need, the main tools that you're going to need is, number one, you're going to need a good soil probe. And as I mentioned earlier, you're going to need like a computer and or something with a GPS unit so you can georeference those samples. You're going to need the sample bags to mix your sample up, and then usually a plastic bucket. And the reason being is as you're grabbing those 8 to 12 cores from that area, you're going to put those into a bucket, mix them up, and then dump that into your sample bag. Unless you really want to take the cores and dump the cores right into the bag itself. I've seen some people do that. The couple things to note is this is the biggest thing, that information is vital. So you want to make sure that if you're pulling a sample and you're at spot number 1, make sure that your bag is properly marked as well. Not only that, but make sure that the correct field, that the correct grower name, make sure that information is correct. The other thing too is once you take a sample from an area, you want to make sure you clean out that bucket really good. And that's where a plastic bucket is good because they're really easy to clean out or keep, to get any excess residue or soil out of there. And the same thing with the probe. You want to make sure you have those properly cleaned out, because if you have some of that carries over from one sample to the next, that could once again skew the results once it goes to the lab. So that's kind of the basics of what you need to think about in terms of tools and things to keep in mind when you're out there pulling a soil sample. Anyone can go pull a sample. We've done that a lot of times here at the college. We've just pulled our own samples, worked with a local agronomy company to send our results off to the lab. So we don't have to pay the local agronomy company to come do it. Anyone can do this. So you send them out to the lab. Lab comes back with the results. What's listed here is these are kind of the common measured values that we see. Your good old N, P, and K, nitrogen, phosphorus, potassium, as well as pH, the buffer pH, organic matter. A few other things you see is the good old cation exchange capacity, or Cs. And so that's more common ones that you see. Typical hard copy report looks like what you see there on the screen. I have a couple samples posted here, but I also have those same samples posted on a Blackboard, so you could take a look and see what those hard copy results look like. The one there you can see on the screen is right now I'm looking at, there's 10 samples right there that I'm looking at, and I could see, what was the phosphorus, what was the potassium, the magnesium, calcium, the pH, CAC, CEC, it's all on there, along with some other vital information is that considered high or is that low, things like that. So that is the lab results. The one thing you want to look at is, when the nutrients, what you see in terms of values on there, in terms of nutrients like nitrogen or phosphorus or potassium, those are always recorded in terms of parts per million or ppm. And also what we see along with that in terms of looking at the nutrients, a lot of those reports will come back with some recommendations. And those recommendations vary by state. Here in Iowa, the recommendations you see on there, and there's a prime example down below, is if my yield goal is 180 bushel per acre, then I'm going to need 216 pounds of nitrogen per acre applied for that one area where this sample came from. That recommendation that's generated comes to us from Iowa State University. They do research all the time, and so every so often they update their recommendations, and you see those being put into that report or the information that we get back from the lab as well. So that's one of the things we look at. Another thing that we see on there is pH. Fairly common thing we look at, and what we're looking at is how acidic or how alkaline that soil is. And there is some, depending on the types of crops, what parts of the U.S. we're in, we see some variations in pH. So typically what we want to see here in the Midwest is a pH that's usually in the range of 5 to 7. If we get some more drier soils, then we want to see that pH a little bit higher, more alkaline. And so once again, this is where we see, we could start seeing fluctuations in that, and that's typically where we're going to have to add lime if we want to get that pH to come up. So that's another common thing that we typically are going to see on a soil test report. Now, as I mentioned earlier, our lab results, they will come back also in electronic form. And the nice thing is, in terms of electronic form, it's going to be, we can easily import that back into our software system. And all we have to do is we just have to match it up by our original sample point. And you kind of see there, what you see down below, that's the raw electronic data format. And for probably a lot of you, as you're looking at it, you probably see there's some columns in there like Smith Farms, some other things. But then once you get a little bit further over to the right, we're noticing that there's a lot of looks like gobbledygook or garbage, and try and make sense of that. But what you see in there, what's highlighted in purple, is each one of those rows represents, here's our soil sample information. And so what's in purple is our sample number. So it was point number 1 or grid number 2, grid number 3. So as long as we match up with those original points, all the rest of that data is going to come in and put it right back into our map. So now we can visually see what our fertility looks like in a field. So that's kind of a key part if you want to do this on your own, is matching up that soil sample number. That is always key, and this is usually when we do training here at the college, if some of you take the software class and we go and we learn how to do this, the key part, typically the most common thing that gets missed is that they didn't match up the soil sample numbers. So what comes off of that? So here's an example. Got this from the folks at Ag Leader. Is over on the left hand side is they did a soil sampling map. Those are 2-acre grids, and sent it in, got the results back. And so what we're looking at here is the pH results. So I can kind of see over there on the left hand side, what's in red is that pH is probably low and I need to do something. So what we could do is, with a couple clicks of the button, we could create a prescription, and that's what shows up on the right is we basically created a prescription map that says, okay, when we go out to this field, here's how much lime we're going to need in this parts of the field, the different levels. And once again, automated equipment is going to make that really easy to do. So that's kind of the whole process from front to end. So going into the next part, kind of wrapping up here with just what do we see coming here right now, what's going into the future. So a couple videos to kind of show you what's going on. Soil sampling is a very laborious process. So once again, innovation is kicked in, and there's people out there trying to find ways of how do we make that a lot better or more easier or more efficient is probably the better word. So this video here is kind of one of those. I've dubbed it, so now we're getting lazy or we're being efficient. I'll let you be the judge of that. So watch this video and notice how see how they're pulling a soil sample from this. So how was that? Kind of interesting, right? Came across this video a couple years ago. Kind of a unique way that they're doing it. You notice the operator didn't even have to leave the seat. Could just drive on to the next part, grab another sample, and have it pop into the bag right next to him. So now here's another one. This company originally, they came out with this probe, and there's actually two videos here. The first one is kind of a demonstration of what it is. And at the time that they came out with this video, their whole approach is we're not going to sell you this probe. We're going to provide you the service. We'll bring it out and we'll grab the soil samples for you. Since then, they've actually had a change of heart, and now you can actually go out and buy this machine. So, and put it in the back of your tractor and do this. So, so go ahead and watch this video that talks about this soil sampling probe.
It's no secret that everything that happens is dependent upon the health of your soil. And soil collection and testing has always been labor-intensive work with questionable results. How do you really know the condition of your soil? Leaving your soil collection to human happenstance is a sure recipe for inaccurate data. When you base your efforts in the field on random information, your results are dependent on chance and human error. The AgRobotics Auto Probe solves this problem and takes the guesswork out of your nutrient management program. The Auto Probe collects 20 soil cores per 2.5 acres to form one composite sample. The Auto Probe is capable of sampling 150 acres per hour with a precision and accuracy that is simply impossible with other methods. The computer-guided GPS-enabled Auto Probe delivers a detailed, accurate view of your soil's nutrient levels. It becomes the foundation of a highly effective soil management program, allowing all your precision ag efforts to finally deliver on the promise of greater yield, lower cost, and an increased return on investment. AgRobotics makes it easy. Offering a complete turnkey solution, AgRobotics quickly becomes an indispensable partner in your soil management efforts. Delivering the Auto Probe to your field, an AgRobotics certified technician will collect your soil, send it to a lab of your choice or a AgRobotics preferred lab for results, and assist you in integrating the data into your application program. The time from collection to application is significantly reduced. The data is detailed, accurate, and repeatable year after year. It takes the guesswork and headache out of your fertility management planning. It is cost-effective and time-efficient. It is the key that unlocks the promise of your precision ag investment. Call AgRobotics today and allow the Auto Probe to realize the value in your precision ag program.
So, interesting video, right? So this one here, this is the same probe. What I like about this video is that this is actually a working demonstration. You can kind of see how the whole system works from start to finish. And once again, the nice thing is they can stroll right through the field. And since this is on a tractor, they're actually using auto steer. So they put their guidance in there, and so now the operator could sit there and focus in on the soil sampling part and not have to worry about driving through the field or paying attention to that. So watch this video. So, once again, kind of an interesting approach that this company has taken to soil sampling. And here's another one. And I actually, where you see this video, and there's actually two videos with this. I was actually at this event when this happened. This was at the InfoAg conference a few years ago outside of St. Louis, Missouri. As we returned that day, we were at the local John Deere dealer, and he was set up with this Falcon soil sampler. Got to visit with the owner. Kind of an interesting person to visit with. So once again, watch and see what his take on of obtaining soil samples is.
I'll do it. Okay, we're here with Alan. He's going to tell us about this new soil testing machine that he's developed on his farm. He's a farmer in North Carolina. And why don't you tell us a little bit about how this thing is gonna work for us here?
Well, you want to talk about how it works, or you want to talk about why it works?
Well, let's do why first, and then how.
Well, the why is as we developed it because we as producers saw a need for it. We expend lots of money. We make tremendous investments based on these soil samples. And what we have found over the years is that the inconsistency of sampling. Oftentimes, and we're guilty ourselves, is the lowest paid people on the staff are the ones who are taking samples. Not because they are qualified or capable or have been trained, but because they may be available. But we're making all these decisions, we're investing these monies, and based on the inconsistency of the sample. So our purpose in developing the Falcon was to try to take and get consistency and quality into the sampling process. As a sidebar was the automation, and as a sidebar was the efficiency. But the first focus was on quality and consistency.
Mm-hmm.
So
it's what's strange about soil sampling is it's one of the most important things, but it's also one of the most, I think, probably disliked things in terms of the lack of efficiency that there's been in the past, and just the difficulty in doing it, but the need to do it right. So you have to figure out what that balance is.
it's kind of like painting. You know, it's necessary, but no one likes it. Soil sampling is necessary. Everybody understands the necessity of sampling and doing it well, but no one likes to do it.
Right.
Everybody wants the perfect sample, wants the perfect results, and hopefully they hope they're getting it without knowing. So we developed the Falcon, and there's two things that allow the Falcon to operate and be successful. One is the wheel. It's a 5-foot diameter wheel, and on this wheel is one probe. So, and it's ground driven. So with this probe on the 5-foot diameter wheel, every 15 feet, when it's lowered, it's taking a core. So you drive as much as you want, as far as you want, take as many cores as you want, and as you're taking them, it's continuously mixed. Let me show you.
Okay, yeah, let's take a look at this thing in action then, if we can.
Now?
Yeah, let's go ahead and run that.
Okay,
thing.
let's, and I'm putting the soil into it. So the wheel goes down, and pretend now it's being ground driven as it's going across the field. And so you drive as far as you want, get as many cores as you want. Then you raise the drum, and as you raise the drum, there's a 12-volt motor. That they can engage, and you continue to mix this sample to get a homogeneous, well-represented sample. Once it's mixed, bring a funnel in, and when you bring the funnel, it opens up the tray. Soil flows into a container. When it's empty, when the drum's empty, bring the funnel back out, closes the top, the tray rotates to the next position.
Okay, can you open that tray for us?
That's how it operates. And there's 12 containers, so 12 unique samples, individual. And all of this can be done without stopping. The only time you have to stop is when all 12 samples, all 12 containers are full, and then you stop and change containers.
Okay, I'm going to go around and show the container
Sure.
storage in the back.
Have the storage on the rear. This box holds 12 containers, 144 samples, so with one in the carousel on the front, have 156 samples that you can take, all with the machine.
Terrific. And at this point, the price point is
Price point is 49,000.
okay.
Hopefully it's going to be a little less, but somewhere right in that range.
Well, terrific. Well, thanks very much for the.
Well,
Oh, we got one more thing. Okay.
Because you never see it. And what the other thing that allows it to operate is the probe. And the probe is chamfered on the outside and chamfered on the inside, if you can see.
Okay.
So the smallest point of the probe is the point of entry. As it goes around, the dirt and soil is continuously released, allowing it to fall. In addition, this probe is two-piece, has a replaceable tip. So as the tip wears, it can be replaced, minimizing the replacement cost. Probes, we can go from 4 inches in length up to 12 inches in length, and with consistent depth of sample. It's very important. Entire system is patented, have a utility patent from one end to the other.
Terrific. Well, it's a really interesting unit, and I appreciate you sharing with us today, Alan.
Thanks, Paul.
All right, so once again, kind of an interesting approach that he's taken with gathering soil samples, and so yeah, and here's kind of a picture. This was my picture when I was there that day, and I stepped back and took a picture. And we're actually going to have one of these rigs is actually going to be at our college sometime soon in the very near future. We're going to see a live demonstration of it up front. So that's kind of wrapping up this unit on soil sampling. Head out to Blackboard, where I've got a couple activities and exercises and assignments for you to do. And so this kind of concludes the video series for this unit. Thanks again for watching and listening.